All right, so today we're going to talk about arc length and area of a sector. So first, if a central angle, if theta is a central angle like this here, and you have a radius of r, and the length of the arc right here would be radius times your radian, where radian is measured, the angle is measured in radians. You have to make sure it's a radian, or you have to change it to a radian. So like down here, we're going to change these radians. So all this right here is the arc length is going to be 3r times your angle, 5 pi over 6. So we get 15 pi over 6, which reduces to 5 pi over 2. And this is in feet. So this right here would be 14.5 inches times pi over 4. So that gives me 28 pi over 8 inches. Down here, same thing. It's just a bunch of problems. So 0.5 times 3 pi over 2. So we get 3 pi over 4 yards. So these are also radians, so 6.2 times my 2 pi. So I get 62 pi over 5. And if you write these as decimals instead, that would be fine with me. Now down here, I cannot use 15 degrees. The first thing I need to do is do 15 times pi over 180. So we get pi over 12 when you reduce this. And now this is what I'm going to use. So 8.4 times pi over 12. So 7 pi over 10 meters. Okay, and then, so this one has to be 135 pi over 180, because I'm multiplying by pi over 180 still. Reduce that down and get 3 pi over 4. So I'm going to use that angle. So S equals 25 times 3 pi over 4. That gives me 75 pi over 4 kilometers. Okay. So now some word problems. We're going to have to figure out what they're giving us, and we're going to solve for what's missing. So it tells us a central angle in a radius in a circle of radius 6. So my r is 6. I'm going to write that down. R equals 6. Has an intercepted arc length of 10 meters. So that tells me my S is 10. Find the measure of the degree in radians and the angle in radians and degrees. So I would just do 10 equals 6 times my angle. So my angle is 10/6 or 5/3. So that is in radians. I should have put radian there. So to get into degrees, I do 5/3 times 180 over pi. So that would be whatever, I haven't multiplied that out yet, sorry. 5 times 180. So it'd be 900 over 3 pi, or 300 over pi. If you wanted a decimal answer, you could say it's approximately 95.5 degrees. All right. So a merry-go-round rotates 2,808 degrees per ride. How far would a rider seated 8 feet from the center, so my R is 8, go around the traveling? So then we're trying to find S. So we don't know S. And I have to change this to a radian. So I'm going to multiply it by pi over 180. So that gives me 78 pi over 5. So then S would equal R, the radius, times the 78 pi over 5. So we get 8 times 78 divided by 5. So it is exactly 124.8 pi feet. But we wouldn't say that in real life. We would say it's about 392.1 feet. Okay. So now onto the back. We're talking about area. And the area of the sector is just going to be 1/2 our angle in radians times the radius squared. So 1/2 theta r squared. Or this has to be in radians. So right here we have, that's 4 centimeters. And you can't see this right here on your notes. Hopefully you can see that says 74 degrees. So I'm going to change 74 degrees to multiply by pi over 180. And then reduce that. So that's going to give me 37 pi over 90. So then my area equals 1/2 my angle, 37 pi over 90, times my r squared. So type all that in and you're going to get approximately 10.3 centimeters squared. Let's see, R right here. So this angle right here says it's 205. So I'm going to multiply that by pi over 180 and reduce it. I get 41 pi over 36. So my area is 1/2 my angle times my radius squared. So that's going to be approximately 224.4 feet. It says 2 pi over 3, so that's a radian measurement. So I don't have to do anything to it, so I can just plug that one straight into here. And then times 7 squared. So that's going to be approximately 51.3 kilometers squared. This one right here is 19 pi over 12. So I'm going to have 1/2 19 pi over 12 times my radius squared. So it's about 1385.2 meters squared. So our last two. The area of a sector of a circle has a central angle of this. The area is that. Find the radius. So area is this. We have 1/2. I need to change this to a radian. So I'm going to do 2 times pi over 180 and reduce that. That'll give me 4 pi over 3. And if you don't know how to do that in your calculator, if you have a graphing calculator, you just do 240 over 180 and you can hit math, enter. Some of your guys' calculators also have a fraction button where you can reduce the fraction that way. Mine does not have that. The newer ones do. So then I have 1/2 of the 4 pi over 3 and then my r squared. And I'm just going to try to solve for r. So let's see. I'm going to do 134 times my 2 and then times 3/4. I'm going to divide that by pi. So that's almost 64. So I'm going to go ahead and say 64. So then my r would be 8 feet. I know it's feet because that was feet squared right there. All right, windshield wiper arm to the left is 32 inches long. If the wiper sweeps through the angle of 125 degrees, find the area swept by the blade. So 125 degrees, change to a radian, would be 25 pi over 36. It tells me that the radius is 32 inches right there. Sorry, the computer's a little slow. All right, now it caught up to me. Okay. So then I have 1/2 my angle times my radius squared. So, let's see. Hold on. I think I read this wrong. So this whole thing is going to be, so this area is, oh, so this right here is only 11 inches. So what's happening is that the blade right here is not swiping the entire thing. So there's 11 inches that won't actually get swiped on your the windshield up here, it's saying. So that's what this picture is. So then I'm going to have to figure out what that area is that's not actually getting swept. So that's an 11 squared. So that gives me 132 inches. And now I'm going to subtract these, and that will leave me with what this area right here is. So then the area is, so right there.